The first one, back to 1998, was not exactly the actual one I had the Science Museum picked up on, but this was radio frequency identification device, and this was implanted in my upper left arm, and it identified me to the computer in the building here. In the doorways, when you came through the front door, you may have noticed there's a big coil of wire either side of the doorways, which the current in that excites the coil here, provides a current for this to transmit a signal back to the little, from the little coil to the coils in the door frame, which identified me to the computer, which is linked into the coils of wire. So at various points in the building here, when this was implanted, I walked around, the computer knew it was me because of this, so we got it opening doors, switching on lights, saying hello, all sorts of things. Partly it was looking at what's possible with an intelligent building. When the building knows who it is, what can it do for the person inside? Partly it was saying, well, with an implant, what can you do as your body when it's part of you in terms of changing your environment, dependent on who you are, where you are, and so on. So that was the first one. Technically, there wasn't an enormous amount to it. I think it was as much of a philosophical thing at the time that you could have implants like that, and hence you can get the world around you changing because of what's in your body. The second implant that I had was this very, very small device here. This is, whether you can see that, whether you can pick that up, I mean it's very, very small. Get the best you can on it. But this consists of 100 small spikes with electrodes on the end of them. It's called the Utah Array because it's made in Utah. It's now, we were in competition with a couple of groups in America to be the first to implant it in a human, and we won the race. Subsequently then they renamed it the BrainGate system, so they could be the first to implant the BrainGate system, but it's exactly, it is the same thing. This was fired into the median nerves in my left arm, and literally was fired in, so a little mechanical hammer, bang, 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 into the nervous system. And I then had wires running up my arm from where it was implanted and coming out at this point here. So I'm not sure whether you can pick up the scars where it came out. So literally, with 100 electrodes in my nervous system, we could pick the signals up. If I open and close my hand, we could pick those signals up here, neural signals, and send them into the computer. And also play signals down into my nervous system that I learnt to recognize. The sort of signals we could pick up, motor signals, so exactly the same if the implant had been put in my motor cortex and I thought about moving, but when I think about it, my hands move. If you're paralyzed, you think about moving, your hands don't move. But using motor neural signals, and so we got them to operate a robot hand, or to switch on lights again, or to drive a wheelchair around, all sorts of different things directly from the motor neural area, partly with a view for somebody who's paralysed, as subsequently has happened with Matt Nagel, so that they could control technology. Could say just by thinking. It's not just by thinking about it. If you're paralysed, I guess it looks that way, but you're thinking about moving your hand. If you're not paralysed, your hand moves. So it's the motor neural area, so that they could control things directly from the brain, which is what happened. So using the same signals. But also it took just over 6 weeks for my brain to learn to recognise pulses of electricity we were putting into my nervous system. So I had to learn to recognise them. And then we did different things, like put on an ultrasonic hat and essentially the pulses stimulating my nervous system increased in frequency the closer an object came. So I was able to move around with a blindfold on and detect objects and how close they were away. So it was experiencing, at least extending the sensory range to take in ultrasonic signals, which was great fun. Yeah.
So where did the research with ultrasonic sensors take you?
I think potentially with the ultrasonics there's the possibility of somebody who is blind using it as a different sense, as it were. We've now gone, if you like, back a step with that, and I have 3 students who have magnets implanted in their fingers. So this is not neural implants, but it's less invasive, just permanent magnets. And what we do is put a coil of wire around the magnet, and the ultrasonic sensor stimulates the magnet. So the ultrasonic sensor, something comes closer, it changes the current in the coil, which vibrates the magnet. So the person can feel by touch, this magnet sense, how far objects are away. So it's a sort of halfway, it's a more practical, more potentially immediately useful. We don't have to go into the nervous system or the brain, but literally with their finger they can detect how far objects are away. So it's replacing the white stick or something with a finger, effectively. And at the moment we're looking much more practically at that, but it has other immediate applications, one of which I can't tell you about, so I won't. But there are quite a few vehicles out there on the roads that now have ultrasonic sensors on them. And again, cybernetics, driver, car, sensors. So trying to link the driver in with the sensors on the car so the person and the car become one is one of the things we're looking at now. So you feel if your car gets close to an object or a car in front, you actually feel it. Literally you feel it. It's not, information saying, yeah, you are now within 1 metre. It's getting close, I can actually feel the thing getting close. So that's directions where the ultrasonics is literally going. But again, with the magnets, we've extended that. So not just ultrasonics. Ian, one of my PhD students, has now fed in infrared signals, so he can, infrared is like a heat signal, so he can point at an object and remotely feel how hot it is, which is interesting. We, as humans, we don't have that, but again, it's into a touch sense, so you get this vibration more, yes, you are hotter than you, and you are hotter than you, and things like that. There's some potential immediate applications. It's not so much one that is therapeutic in a way, but I mean it is enormous fun playing. I haven't had any of the magnets implanted myself yet, but I think they're having too much fun, and I might well join them. It's not too invasive. So.
Are there any robots that you created with the ultrasonic technology, or any?
We have a range of robots that ever since I've been here, which I came here in 1740 something, I think, or something like that. I've been here a long time, which I thoroughly enjoy, and we built some very small robots a long time ago, the 7 Dwarfs, which then became the Cybot as a commercial product, but also we use different versions of them. So, for example, these things. So this one, I won't run it for too long, but then the battery's down. But what it's doing is learning how to move around and not bump into objects, which sounds as though it's learned how to move forwards because it's not bumping into anything. And it's using ultrasonic sensors. So ultrasonics are quite cheap. We know how to feed them into a robot. And with these things we can look at how the robot learns, and then they have modules we can put on top of it, infrared, so they can communicate with each other, and so on. So we use ultrasonics in robots like that, but then most recently, of course, this is a physical aspect of the robot. These are bigger ultrasonic sensors. Robot other than that is pretty much the same. This one is just the basic physical shell, the body, ultrasonics as input, wheels as output for it to move around. Rather than with this one, it's simple microprocessor or PIC chips we use as the thinking, if you like, process of the robot. But for this robot, what we do is take rat neurons and separate them and put them in a little dish here. The dish has electrodes on the bottom of it, and within a couple of days the neurons have linked up in a quite complex way. We feed the brain every maximum 2 days, sometimes a bit earlier, with minerals and nutrients, and after about a week it's complex enough that we can link up the electrodes here to the robot body. So this has the brain, this is a biological brain, and this has the body, and we put the two together. We actually connect them via a Bluetooth connection, which means that the brain and the body don't have to be in the same place. But to be honest, that's true with humans as well. We've just evolved with our brain and body in the same place. Long term, who knows? That's a limitation we don't have to live with long term. Another potential enhancement is brain one place, body somewhere else. So this is our latest robot with ultrasonic sensors, but with a biological brain.
So with the second implant, did you manage to connect to any hands or or any other machine?
I did, and if my trusted assistant could help me with the hand and the
is that this?
Just pick that up and throw it across. Well, don't literally throw it across.
No, it's heavier than I thought it would be.
That is a problem. That is an issue
Is that
with it
the
in a
real
practical
hand?
sense. That is one of the real hands. We actually had two of these things.
I thought that would have been in a museum somewhere. Sorry, I'll shut up now and get out camera shot.
Yeah, no. We still use it for various TV people coming and things like this. Right, this hand actually didn't go very far. This hand stayed in the lab just down the corridor from where we are now, but I did travel far with the implant in place. I went to New York, to Columbia University, where we plugged my nervous system into the internet, and literally as I moved my hand in New York from the implant, my neural signals went across the internet to move the robot hand. So the robot hand mimicked my hand movements, controlled by my neural signals. So it was like an extension of my body on another continent. But you may notice they're a little bit worn, but the robot has little sensors, and also in the fingertips here. And as these press on an object, signals for the experiment, signals were sent back across the internet to stimulate my nervous system in New York. So I could feel how much force this hand was applying to objects on another continent. So one of the things it was showing is that if you lost a hand, you had it amputated, or you can't control a hand, maybe for multiple sclerosis or something like that, you can control all sorts of technology, including robot hands, directly from your brain, and you can feed back to your brain the signals that you're actually getting fed back and so on, and understand them. Your brain is very plastic and you can understand them. But in the enhancement side of things, your body can go where you want to go. So that was one part of the experiment. Part two, I guess, was the ultrasonic input. actually experiencing ultrasonic signals and using them. And part 3 that was important, apart from things like controlling wheelchairs and those are the things you do every day from neural signals, part 3, the most important bit for me, was my wife had electrodes pushed into her nervous system, 2 electrodes, and we came back to the lab here and linked our nervous systems together. So how it worked, when she closed her hand, effectively my brain received an electrical pulse. So every time she went doop, 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 got 3 pulses or whatever. So it was telegraphic communication, technically from nervous system to nervous system. I mean, if you think of the nervous system as being connected to the brain and so on, so you actually were getting signals from brain to brain, if you want to look at it that way. But it was really, if you think about how the telegraph system works, Samuel Morse and all that, you press a button, so you've got thoughts here, those are converted into mechanical signals to press the button, and then you've got electrical signals across the wires. At the other end it's some sound output, again mechanical signals for you to pick up dots and whips and things like that, and then it's back into electrical signals, so you're going electrical, mechanical, electrical, mechanical, electrical. And these mechanical elements, the movement and the pressure waves, are incredibly slow, incredibly error prone. There's just a very, very low bandwidth. The interface problems are the issues. And when you read what Sam Morse had to say, I mean, he was looking at trying to communicate from brain to brain. That's what he was trying to achieve. And the connection, electrical connection, yeah, fine, you shove as many signals and whatever you want to do there, but the interface is the problem. So we were just overcoming the interface problem and going straight from brain, nervous system, onto the wires, electrical signals, and then at the other end, wires, nervous system, and so on. So for me, it was a very, very important thing to just do this first nervous system to nervous system communication. I think there's some people who still don't understand what we're actually trying to do with that, which is a shame.
Aware of the time, Dan, do you want to just move on to the marked questions?
Yeah, okay.
We're very much aware of the time. I think we're at...
Question 2 out of 6.
2 out of 30, yeah. When you have had these implants implanted, for lack of a better term, did you have any troubles travelling? Because at the moment when you try and fly, you have to turn your phones off, you can't have this, can't have that. How does it work being a cyborg flying? Did you have any issues
travelling? Was not with a problem with the actual implant, because the amount of metal in these little things here, you know, the amount of metal in that, and it's platinum and so on, there's bits of silicon shafts, is compared to what you have in a filling or in a watch is nothing really. So there's no problem picking it up. Where we did have problems, another prop here, was things like this. When I went to do the New York experiment, I took this gauntlet in a metal case with me. This was this was how to connect up. This held an antenna and a power pack so that I could do that. It was connected into my nervous system and so on. But we had this in a little case, and when we're coming back through Newark, I think we were flying, they said, right, open this case, and they looked at this and took one look at it. What the hell is that? And I said, well, I'm doing some cyborg experiments. Oh, yeah. So they marched us off, and we had all sorts of, even though we had some letters from doctors and things like that to say this is what we're doing, and eventually they let us get on the plane. But it was an extremely hairy moment when the more we said, the more we dug a hole for ourselves, and you know, the more they were into some science fiction story that they didn't believe and so on. So just like nervous system to nervous system, send the funny farm and all that sort of stuff. So it was not a problem flying with the implants per se, but the gizmos and stuff with them was an issue, because they all looked a bit strange for boring old customs officials in New York who are not used to, even with years of Arnie Schwarzenegger, they're not used to it really happening, especially not from some Brits who are not wearing bowler hats.
I'm never allowed to do a project again.
Bottom of page 1, third question up. Second best.
Oh, what do you say?
Okay.
Did I say?
Sorry, I do apologise.
Was there ever a moment where you were worried about being a cyborg?
There wasn't ever a moment I was worried about being a cyborg. There was lots of moments where I was worried about not being a cyborg. For me, the whole project was extremely exciting, and I wanted to go for it and find out. And to be honest, I had a doctor about 3 days before the experiment. He said, "Look, if it goes wrong, you could lose the use of your hand. There's a high probability of that. Do you want to stop?" Of course not. Let's get on with it. But there were a lot of people that were perhaps somewhat nervous about what might happen in the university, the surgeons, various people that were associated with it in terms of different charities and so on. What might people think of this? And having their, their names associated with it, and people are talking about cyborgs. I mean, cyborgs, I think, before the experiment, cyborgs were more science fiction, linked to Arnold Schwarzenegger, and to actually talk about, and even now if you read a dictionary definition, it will probably say, oh, it's a fictional character. The fact that there is scientific research going on, so it was making that step. Hey, we can start to bring about cyborgs. So I think some people were nervous about it. So the last few weeks, it was a difficult time to keep the project together, to make sure the implant went in, and then when it went in, we could get on with experiments. So I was worried a lot about not being a cyborg, more through the silly Jobsworth bureaucrats that were more. But I think as a scientist, you sometimes you just have to put your head down and go for it, and what the hell. If you only live once, and either you listen to the bureaucrats, that's a good word, I have to...
We've got that on camera, that's
yeah,
fine.
well it could be a good word, the bureau, I will use that again. Either you listen to them, and you don't do the sort of projects that you want to do, or you get on, and this was ethically, it's not hurting anybody. We just want to get on and do some experiments. Some silly insurance person or whatever, oh, I can't do that, there might be problems. Oh, sod off. Yeah. Shouldn't say sod off, should I?
It's fine. They're all over 16.
Scientists don't say sod off, do they? Or bureaucrats.
Do you
I think
think
that will be the new word. I don't think
We'll make sure it's credited to you.
Good, yes. Well, Faraday got electrode and all that sort of thing.
And the cage.
To him. Yeah, yes. So I'd have bureaucrat, yeah.
Do you think humans will ever become a subspecies?
Yes. I do feel that on the one hand, with upgrading humans with technology, it's upgrading the intelligence. Yeah. And intelligence is what we are, and if you look and you compare us with other creatures and things like that, it's our intellectual abilities that put us in a fairly dominant position on Earth, I would like to hope anyway. So if we upgrade those intellectual abilities, particularly in terms of communication, sensing, motor abilities, these are all very, very important aspects. And then you link in memory capabilities and thinking in more dimensions. Wow, blimey. So intellectually, cyborgs can be way ahead of humans. Therefore I think that once a number of those who are presently human see what the possibilities are, there'll be no stopping them. There'll be a whole load of people that want to jump on the bandwagon, but there'll be some, probably, the idiots that want to stay as just humans. That's their choice, that's up to them. The species aspect of it, I think, is interesting, because if you literally go down the line of what's been called Darwinian evolutionary theory, I mean, he would say, well, it's just a genetic thing. Man, woman come together, the genes produce an offspring, and that's it. If you look at Lamarckian theory, it would say that what that person does in their lifetime affects their genes. Habits change the genetic makeup. And then if that's the case, you're looking at a potential species shoot-off. That cyborgs become more linked in, new sensory input, new means of communication, and whoosh, off they go, and humans stay pretty much as they are. I have to say I am more, shouldn't say it maybe, but I am more of a Lamarckian supporter. I feel that habits and what we do, and it does seem to be borne out in DNA research, genetic research, practically it's more, I feel, much more sensible. And therefore, I do see the cyborgisation and upgrading intelligence as creating a new techno-species which will leave humans as they are behind. I don't see that's a bad thing. If people don't want to move forward, fine, then there'll be something of a subspecies. So there. How cyborgs regard this subspecies of humans, from Nietzschean philosophy, the Nietzschean Superman, probably not very well. It's, why should you listen to somebody who's still communicating in this stupid, old-fashioned, trivial language that we have as humans? It's just these stupid noises to cyborgs who are communicating by thoughts and images and emotions and concept to be much, much higher plane. So I don't know why cyborgs should bother listening to humans at all. So maybe push the humans off onto some island somewhere and we'll move forward with the future as cyborgs.
I wasn't expecting that answer. Another couple of...
I have to say, there's no way I want to be a human long term. If the technology, we can prove it enough and show it enough, then I want to be a cyborg.
Just while Dan's getting his next question, you've referred to various science fiction points throughout this last 45 minutes. Just like Star Trek, Star Wars, Stargate, two-part question. One, which is your favourite? And two, are any of them plausible, probable, or are they all completely unrealistic in your expert, professional opinion?
I think one aspect of science fiction I have issues with is time travel. I know practically moving forwards in time at different speeds, fine, but actually going backwards in time, or to different, jumping ahead, with time warps and things like that, and then coming back again, I have difficulty seeing how that's possible, even with my imagination on a scientific front. So Stargate, I'm probably not all that.
I believe you're right in saying you were on a TV special about the science of Stargate.
I was on science. Well, looking at some of the science, I think every science fiction program, story, theory, whatever, has some good points and some bad points. The Terminator, I absolutely adored the philosophy behind that, except the time travel. The whole, which I still have an issue with, the time travel backwards. Forwards time travel maybe, but the backwards time travel I still have issues with. And with the Terminator, the thing that we could get this machine to smell like a human, to think like a human, to act, but it's a machine, so you can't, it doesn't value humans. Yeah, I can go for all of that. Star Trek, I think you get some little gizmos like the cell phone. I think dematerialization is an interesting one. That I wouldn't put completely out. How you rematerialize something in exactly the form that you want, there is an issue with, but actually taking them and storing them and putting them somewhere else. possibilities. But again, any time travel thing in Star Trek, I don't think they did. Going fast through space, I think if you open up the possibility of more dimensions, which, yeah, there are. I mean, as humans, we're just looking at some puny three-dimensional view of it, and we can't do this. Well, of course you can't in 3D, but as soon as you look at it in 20 or 50 dimensions, it's a whole different ball game. So the travelling, zing, and you're into a different, I mean, it's just more dimensions that you're looking at. I guess I do even now, like little stories. I love Jekyll and Hyde. I mean, I know that's an old story, but the whole concept, again, I think I read it first as a child, and I read it every 10 years or so because it is the most brilliant book, the actual book. I know it's been characterised and things like that, but brilliant book by Stevenson. And the whole concept of taking this chemical and changing how your brain operates. And I'm just looking at it differently. This is looking at electrically, taking electronic signals and changing how your brain operates, is incredibly exciting. And I don't know that I would. There's bits here and there. I don't know that I'd want to choose this. I like the Terminator. I don't know that I like Terminator 2 so much, with this body that sort of melts and comes back again. I wasn't fully. How do they do that? I'm afraid I look at things disgustingly scientifically, and if it's fairly plausible, or I can extend to the plausibility, I'm all right with it. If it's not, I have sort of cringe a little bit and go, if someone then said, well, actually we're doing it this way, then okay, then I want to know I can watch the thing. I have to say I'm disgustingly irritating. I'm one of these that I'm a continuity person, and if somebody is smoking a cigarette and it suddenly gets bigger and smaller, and if you get 3 or 4 of those things, I can't watch the film, which irritates my wife because she's just getting into some romance thing, and I cannot watch anyway. The coffee has just increased in the cup, and it should have decreased. I can't go for that.
How about the Cybermen in Doctor Who?
Great. Yes. I think Doctor Who is an intriguing science fiction. Again, you've got issues of how the thing travels around and regenerating doctors. But the Cybermen, it would be nice to credit them with a bit more intellectual ability, I think. But the linking, the way they can operate in a mechanistic fashion and in a more military, they're all operating in the same sort of way, which was the same sort of story as picked up in I, Robot, where you've got the robots that are controlled from a central brain. Yeah, I mean, I go for that side of things. I think it's not necessarily the case that they all behave the same way, but I do link it to human behaviour, that we're looking at these machines that are behaving, they're all sort of programmed and behave the same way. But a lot of, Oxford University students are exactly the same. This is how you've got to think. You can't think outside the box. Which, humans can adapt the way we're thinking, and why don't? So I never believe everything that somebody tells me. I always question a little bit, whatever it is. Is it really the case? If you just believe everything, and because this is an important person, they're telling you this, so I'm going to take. No, I mean, otherwise you're just becoming like the Cybermen. So how much those Cybermen relate to robots and cyborgs, to an extent, but also I think they make me reflect on some of the bad aspects of humans.
So why hasn't being a cyborg already become mainstream? I mean, the research has been done at least a decade ago. I mean, why haven't industries taken it up?
I don't know why it's not been picked up more, or I know the military are funding a couple of groups in the US, and it has gone somewhat further than we know about as yet, but not that far. I think there are a lot of issues in terms of still messing around with some healthy individual's brain because things can go wrong. There are issues in terms of longevity of implants. You know, you're still looking in monkeys. I think some monkeys have had some of the implants 2 to 3 years. Certainly, if I believe what the other scientists are telling me. But for humans, it's still 7, 8 months, I think, is the longest one. So you've got the longevity of the things. But I honestly don't know why it's not been picked up more. Still, most of the research is more therapeutic, and it does take a while in that area. When you look at the first cochlear implant, you could say it was about 1950, but the first commercial one, you know, some 20 odd years later. The same with sort of Parkinson's disease. It takes time for the initial research to go ahead. But yeah, I think some of the potential results are, when we did our, and even doing the projects we're doing now, didn't really have an immediate commercialization plan to follow. I'm not interested in money at all. I just love the research I do, and that's what my life is about, and so on. So we did the project, tick it, now what project are we doing, rather than did the project and say, now I'm going to make some money out of this. No, that's not me at all. So it probably needs others to come in and say, okay, we can. I think I have to say I'm sensing there are commercially nosed people who are sniffing now, but I think it takes quite a few years for the message to get out there and for people, hold on a minute, there's an opportunity here, and then the money starts coming in. So it wouldn't surprise me if it starts to be picked up in the next, just the next handful of years, and that will develop the thing into more commercial aspects.
So communicating from brain to brain is it sounds really, it's a great dream to have. Can you predict a time in the future when it might happen? I mean, like a say 10, 20, 30
I think the first research project communicating brain to brain will be in the next 3-4 years. That will be done. Commercially, it's so difficult to know. It's how quickly the things get developed, how quickly people accept it, how much it pushes the technology on, so that it is something that you can very easily just press that into your brain. I mean, now with cell phones, a lot of people are living with the things. I mean, I've seen people walking around town with 2 cell phones, just holding them on, and they're talking, blah, 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 nothing. And they're just, this is where they're communicating. So the next step, which people have cochlear implants, which are not too much more invasive than cell phones. So we're nearly there anyway. I think research projects for thought communication the next handful of years, commercial exploitation of thought communication, which will be absolutely enormous. I can't say how quickly that will take off. Maybe 10 years, maybe 20, maybe 30. It just depends how much the commercial vultures get involved quickly.
So are there any steps to, really sort of defined steps which will lead towards the eventual ability to be able to,
for thought communication?
Yeah.
I think first of all we do need the first brain-to-brain communication.
Right.
To tick the box on that in a simple form, telegraphic form. We've done it nervous system to nervous system, need to do it brain to brain. Yeah. Tick the box. I think then to extend what's communicated rather than just a simple motor signal and receiving it. Maybe if we could pick up a signal to do with excitement or shock or anger, so somebody, again very simple, but somebody can show, look, when I get excited, this person feels it in their brain. They can start to detect my emotional state accurately, 100% accurately. As opposed to at the moment, you're just guessing really at somebody's emotional state. I say those things would be the first step. The other aspect would be the more reliable implant or means of connection, the less invasive it is. I mean, literally now, if you could stick something on the outside of your head, and I could stick something on the outside of mine, and we could communicate by thoughts, you'd have the product now. I don't think people go, you have to have your head shaved, who cares? Well, people would go for it now. So there's clearly an element of the, because it's invasive to some extent, it's a bit dangerous, it needs medical and so on. So partly probably socially people getting used a little bit more to implants, but something, the bit of development that it's going to last a long time, and it's not perhaps quite so invasive.
Just one more question, Michael. If you are able to disclose, what are you currently working on?
Yeah, I can disclose. I'm working on a whole bunch. First of all, I'm working on brain-to-brain communication with surgeons, and we're looking more at the area of the brain that we're going to put implants. One aspect, but with the brain, it is partitioned in how it operates, and we're trying to see, can we get the motor cortex to learn to receive signals as well as send them? So that's one thing, to bring about brain-to-brain communication. Secondly, working with surgeons on Parkinson's disease stimulators to make the stimulators intelligent so that they only stimulate when they need to stimulate. They operate a bit like a heart pacemaker does. That means we're using AI to learn the electrical activity in the brain of the Parkinson patient, so that it can predict from the electrical activity when the tremors are going to start, before they start. However, in using that and looking at the electrical activity, it's giving us quite an insight into Parkinson's disease. And my suspicion is that there isn't in fact just Parkinson's disease. There are perhaps 4 or 5, certainly 3, different types of neurological problem that are all at the moment under this umbrella. So partly it's what I'm doing at the moment is a medical thing. I've got a whole bunch of students that are analysing the data from people's brains, if you like, and trying to understand what's going on with Parkinson's disease at a very basic electrical level, what's going on electrically in the brain with that. I think that will have spin-offs to epilepsy and Tourette's syndrome. The big hope would be if it had a spin-off to schizophrenia. At the moment it's difficult to home in where exactly in the brain, so there's many more issues in that. That's the big one, but I do have a surgeon who is also a research student, so he works in the day as a research student, works in the day as a surgeon and at night as a research student for me, and he's looking specifically at electrically diagnosing schizophrenia and therefore chopping it up for treatment. And then with the rat brain robot, which we were looking at before, rather than using rat neurons, using human neurons, and rather than having something like 100,000 rat neurons, we're constructing a little lattice scaffolding, as it were, which will allow us to culture about 30 million human neurons. So we're looking at robots with 30 million human neurons driving them around. We will have to give them a lot more to think about, a lot more inputs, because they'll be getting pretty bored with just the odd ultrasonic signal coming up. So those are the 3 main areas. I have to say one other thing which is of interest is what's been held as the Turing test. It's Alan Turing's, would be his 100th birthday, it's the 100th anniversary of his birth next year. So it's timely to look at the Turing test and where it is. So I'm involved in what's called Turing 100, and will be involved in running, but part of the organisation of a key look at the Turing test and different machines and seeing can one or more of them crack the Turing test, get there. I think that will happen next year, and so I'm part of that. So it's a more normal thing to be associated with, but it's tremendously exciting. I think Alan Turing was a genius, well ahead of his time, deserves a lot more recognition. He was treated very, very badly as a person, an individual, and I hope next year he will be given belatedly more credits and rewards, if he can be, for what he actually said, did, predicted, and so on.
Okay, should we end it there?
Thanks very much. Yeah,
Thank
Can I
you.
have a quick look at reading that neuron, just because I can see it back there, and the RFID? No?
Yeah, there you go. He's on. Yes.
You know about Terminator?
Yes.
It occurred to me that, what about Blade Runner?
Yes. Yes. Yeah, no, I think with the downloading the things and Minority Report, in a sense, not too dissimilar to that. Yeah, I think in different ways, changing the way the brain thinks and changing memories. Memories are an interesting thing. We're trying to figure out what memories are in a brain with our rat brain robot. Change what the robot does and seeing how the brain remembers things. We know that memories can be stimulated. I could put electrodes in your brain, if I got ethical approval and everything. I could put electrodes in your brain, apply pulses, and you would say, oh, I remember when I was a young boy, I remember, and oh yeah, I remember that girl I kissed when I was 7. So you remember things like that. So we can do that. Can we actually put memories into your brain? I mean, I don't know at the moment. That's the biggie. We need to know how is that memory stored? So I would say, well, it's got to be possible, because it's just some physical sets of numbers in your brain, and the brain is going in a certain way. It's got to be possible, but we don't know how to do it yet.
Yeah, that is, in Blade Runner, the androids have memory.
Yes.
So in that film, they had a way to download them on though.
Yeah.
Which I found quite interesting.
Yeah, they must have the way, which I don't think at the moment we know that. It's only a matter of time. I mean, it is a memory is a physical thing in your brain. It's just, but we don't at the moment know what exactly. Some people say it's all diffuse throughout the brain. Others, we know there are regions of the brain that are more responsible, but what that means for short-term memory, for long-term memory, but we still don't know how exactly here's a memory. Where did that come from? Where was it stored? With electronic things, we know here's this bit of electronics, this is where that data is stored. Is it the same in the brain? And when you get something like dementia, what exactly is the problem? Is it the memory itself? Is it how you recall the memory, so the pathways of pulling the memory out? Or is it the controlling mechanism that sorts out how it's pulled out and so on? We don't know. We have no idea. So chemicals reply to the just zonk the person out. If we actually knew a bit more about memories, what they are, then I think we'd be able to get on a bit more with treating Alzheimer's disease, with treating dementia. Even when the neurons, or what's happening here, neurons start dying off, is that what's going on, or is it the connections that are dying off? What exactly is the problem? Then we might be able to throw in a few stem cells, throw in a few fresh neurons, or even stimulate them to make new connections, and that will be fine. Maybe, that we suddenly just inject a few stem cells into your brain in a particular position, and you don't suffer from dementia.
Because that type of research is going to become ever more relevant as
Oh,
time goes on, because
yes.
more people now are suffering from memory-related illnesses. So.
I mean, it's a positive of people getting older and growing longer, is that things like Parkinson's disease, things like dementia, are on the increase. Well, they are on the increase, but people are living longer.
Yeah.
There's the same, I have to say, through skin cancers. Despite what the cancer researchers are to do, try and make more money for their charity, skin cancers are on the increase, mainly because people are living longer. And if you live longer, you spend more time outside, you get more skin, you get older, you get more skin cancer. Sorry, that's the base. So skin cancers are on the increase. Great, this is good news. Let's celebrate, not suddenly give loads more money to cancer research. That's not, but they use it as more of a horrible scaremongering thing. It's good news that skin cancers are on the increase. It's good news that more people have Parkinson's disease. It's good news that more people are suffering from dementia in a strange way. But now we need to tackle those problems more directly. Yes, we need to go for the Parkinson's disease because it is more of a problem. But it's more of a problem for positive reasons.
Okay, well, thank you very much for taking the time out.
No problem. Good talking with you, and hopefully that's been good. Thanks very much indeed. Nice to see you. And thanks very much, Mr. Bossman.
Thank you very much for your time.
Cheers. No problem at all. Hope that's been useful.
Fascinating for me, and hopefully
Definitely for me. Yeah.
Good.